Assalamualaikum warahmatullahi taala wabarakatuh. Apa khabar semua? How are you?
Waalaikumsalam.
Alright.
Alhamdulillah.
Fine, sir.
Okay.
Alhamdulillah, sir.
Everything okay? Study okay? Now, if you have any problem
Okay.
with regard to this subject, okay, I would like you to discuss with your friend. Okay, discuss with your friend. You ask me. So today we're going to go into a new topic. Like I said earlier, we are going to discuss or start with the topic of derivative, which is chapter number 9. That will be the first chapter. And then we are going, to continue. There will be a few chapters that relate to chapter number 9. So let's start with derivative. Now, what is derivative? We are not going to the detail of the theoretical concept. What we need to understand is only the basic, okay, the basic concept of derivative. What should we understand, about the derivative? Now, derivative is the concept is related to slope. So we will start with the idea of slope, which we did in chapter number 9. No, chapter number 9, not chapter number 1. So derivative, we start with the slope. Now, derivative of a function. So let's consider a function y equal to f of x. Now we're going to look at a more general type of function, which is non-linear. So non-linear, linear will also be included. Okay, linear will also be included. Linear and non-linear. Now we start with linear function, because I said derivative is related concept to the slope. Now, if you recall, you have a linear function. The slope, what is the slope? The slope is delta y divided by delta x. And that is a difference between, if we consider 2 points, y2 minus y1, x2 minus x1. And if you look at the line, okay, if the line is a straight line, the linear function, that would be what? It would be the slope. Here you have a point A, point B, or x1, x2, x1, y1, and this is x1, that's y1, and this is x2, y2. So the difference between y and the difference between the x, which you call delta y, delta x, you divide, then you get the slope between the point A, B. And since the line is a straight line, the slope is constant everywhere, slope will be the same. So that is the idea of the slope. Of course, this is what we use when we were talking about the linear function. Now, when we move to a non-linear function, okay, let's say we have a non-linear function passing through that same point, x1, y1, x2, y2, and or a, b. Suppose you have a linear function looking something like this. So you got y equal to f of x, and that is a non-linear function. So you see there in the red color, you have a non-linear function, non-linear line. Okay, it's not a straight line. Now, if you have to find the slope, okay, find m, the slope of the non-linear function y equal to f of x. If I use this formula, delta y divided by delta x, what I get would be what? What I get would be the slope of the straight line AB. Okay, the slope of the straight line AB. If I use delta y over delta x, I get that slope. Which is m lah. Okay, delta y delta x. I use that thing. What I get will be the slope of the straight line. Okay, slope of the straight line AB. But our line is not straight. Our line is a curve. Okay, so this is not a good estimate. Okay, so that one, it's not good. Okay, it's not a good estimate. I mean, not good method. Okay, in order for you to find the slope of the function. So you have to find a better way. All right, you have to find a better way of getting the slope of the curve. So that's where the derivative comes. So a better estimate, which is also related to the m over m equals to delta y over delta x, is the concept of derivative. So we're going to get derivative, to make use of derivative. Okay, now, what is the derivative? Okay, this is the idea. First, it's like I said earlier, it's related to the slope. So what we do here, in order to get a better estimate, so derivative will give you a better estimate, or better method lah. Okay, better estimate to get the slope of the curve. Now, what do we do? What we do here is you make the change in x, make delta x smaller. Right? If I make delta x smaller, then you will see that the slope, okay, the slope of the straight line will be closer to the shape of the curve. Okay, so this is what I want to show you. So make the delta x smaller. And by making the delta x smaller, you can have a better estimate of the slope, better estimate of the slope. Okay, so that is our idea. You want to make delta x smaller and smaller and smaller. So let me draw the line bigger so that we can see better. So if I draw a bigger line, you have the points here, your point A, okay? That's the point B, x1, y1, x2, y2, and that is the curve. I should have drawn it in red, but okay, I forgot. Y equal to f of x. So now if I make, so you refer back from the first diagram. Now if I make delta x smaller, so we started from here, x1, x2. Right? If I make delta x smaller, say by half, okay, it'll be here. So now I make delta x smaller, call it x3. So if I have that, then you will see here, I have y3. That is y1. Oh, this diagram is not very good. Okay. All right. So y3 shouldn't be there. Y3 should be here. Y3 will be here. Be there. all right? Because the B here is that B on the curve. So I have Y3 there. So now what is delta X and what is delta Y? So M is equal to delta Y over delta X. Now you have a smaller delta, all right? So delta Y now is Y3 minus Y1 divided by X3 minus X1. So that the M, okay, now would be the curve, the slope of the straight line connecting point A, call it point C. That will be the line. So that will be what? That will be slope of AC, the straight line AC here. Okay, can you see that? So here I have delta X. From here, delta X. Here is delta Y. So when delta X becomes smaller, you can see delta Y also becomes smaller. All right. So now what happened here? What can you say about the slope of the straight line AC and the slope of the straight line AB relative to the curve? What can you see?
Less steeper.
It's not steeper. If you look at the straight line, it is not steeper. AB, which one is steeper, AB or AC?
AB is steeper.
AB is steeper, so it's not steeper. We are going from AB to AC, bukan AC to AB. Okay, you are going to compare AB ni to AC. What can you see? What can you say in terms of the relationship to the curve? You see, that's the curve, the function. And then you have the straight line AB over here. And then I have a straight line AC over there. Okay. Now, what can you say about the straight line AB, straight line AC, relative to the curve, relative to the non-linear line? Okay, I will do another one. Now, we make delta X even smaller. Let's say here. Okay, suppose this is X4. So now M is equal to what? M is equal to the delta X over delta Y. I'm sorry, delta Y over delta X. That is equal to what? We call it Y4. Okay, Y4 somewhere here. So this is X4. So Y4 minus Y1, X4 minus X1. So that will be the straight line, the slope, straight line connecting that 2 points. All right, now I draw 3 lines. You look at the graph, look at the lines. What can you say about the slope of AB, AC, and the blue line, call it AD, relative to the curve? Relative to the curve between those 2 points. Paham ke tak paham? Okay, you look at the straight line AB relative to the curve AB. Look at the straight line AC relative to the curve AC. You look at the straight line AD relative to the curve AD. Okay, and these all the AB, AC, AD, they are the slope. Okay, the slope. By making what? By making delta X smaller and smaller. So what can you say about the straight line and the curve at the respective interval? Relative. Compare. Okay. You look at the graph, what can you see?
Smaller. Change.
Apa dia? Yeah, it's changing. Okay. You're right, it's changing. All right, changing, number 1. Okay, number 2, what else can you say?
Shorter.
1 is shorter. Okay. 2, good. Okay, 3, number 3. Number one, the slopes are changing. Okay, when you make the intervals smaller, the slopes are changing. You got AB, AC, AD. That's good. And then the lines become shorter. So we're getting closer. Now, once the line becomes shorter, how does it relate to the curve, to the non-straight line?
Tangent.
It's not. Don't use the word tangent yet. Just use. We're getting closer to that, but not yet. Okay. Just use common word. It's not tangent. I think it's not tangent, but we're getting to the tangency point. But what can you say? We can see that. Okay, we can see that the slope of the straight line. Okay, the slope of the straight lines. As you move from AB to AD, okay, I move from AB to AD, you compare to the curve, what can you say? The straight line and the curve, they are what? They are getting what? They are getting more similar. Is that right? They are getting closer. They're getting closer and they are getting similar, more similar. If you look at AB, okay, the slope of the straight line AB and the slope and the curve is too far off. You know, you want to find the slope of the curve AB, but what you get is the slope of the straight line AB. That is too far off. Okay, that's why I say it's not a good estimate. Now, by making the interval, the change in x smaller, you can see that when you have delta x, x1 to x3, the line AC, what can you say about the straight line AC and the curve? They are closer. Is that right? They are closer. They are getting closer. Closer to the curve. Okay. Now getting closer to the curve, that means what? It's a better estimate. As you make it even smaller to x4, you can see the line become even smaller to the curve. So by making the delta x smaller, what happens? You can get what? I can get a better estimate of the curve between the 2 points. Okay, between the 2 points. So what we do, we will continue to make it small and small until it becomes very, very small. Okay, so what we end up with is the following. We will end up with the slope of the line, the straight line, just tangent to the curve at that point A. So that will be the straight line. So what you want to do here, you want to get a better estimate of the slope of the curve. What do? You make delta x even smaller. Okay, smaller, even. Okay, smaller, even. In fact, delta x will be approaching 0. Too small, very small. So what you will get will be what? Will be the slope of the straight line. Just tangent to the curve, okay, y equal to f of x, at where? At that point, at that point, particularly at that point. And what is the point that we're talking about? Point A. So what you will get will be just the slope of a straight line tangent to the curve at that point A. So that is what? That is the best estimate of the slope. So what you got here is you have slope at a point. Okay, slope at a point, because the change in x is very, very small. So we call it slope at a point, or you call it instantaneous slope. Instantaneous slope, or the book call it instantaneous rate of change. So that is the derivative. So the slope of the straight line over here, how do you get it? We get it by the derivative. So how do you get it? You got it by the derivative. So what is the derivative? You consider a function y equal to f of x. The derivative, okay, derivative of function, we call it y prime, or that is equal to dy dx. So dy dx is actually coming from delta y over delta x. But this delta x are very, very small. Okay, delta x approaching 0, very small. So the change is for a very small change in x. So we call it dx. So you don't call it anymore delta y over delta x. You call it dy dx. But it comes from what? It comes from the change, delta y over delta x. Okay, so when you use dy dx, that is what you call instantaneous rate of change. Delta x becomes very, very small, and that is what you call, how do you get it? You call it its derivative. Okay, so the derivative of a function is essentially the slope. Okay, the slope of a function, but not simply the slope. It's the slope of what? Slope of the function at a point. At a point, slope at the point. How do you get it? You will get it by making the delta x smaller and smaller. So the derivative will give us a very, very good measure or estimate of the slope of a non-linear function. And for that matter, it also applicable for a linear function. Okay, any question? Now let's look at a few other points. Let's say I want to find the slope at this point here. It's called a point E. Okay, so how do you get the slope at the point E? So what you do, we're talking about the instantaneous rate of change. We're talking about the derivative. So what you do, you just draw one line tangent to the curve at point E. So that is our slope, call it M. M, you got it. Okay, but now the M is dy dx. So that is the slope. So you call it slope where? Slope at E. Okay, I want to find the slope at B. What do? I just draw the curve, or not the curve, straight line at that point. So that is the slope of the straight line tangent to the curve at point B. So we can find the, is my internet? Can you hear me? Internet say okay. Oh, okay. Internet say dah disconnected. So you can find the slope anywhere. Okay, you can find the slope anywhere by what? By just taking that point. You mark the point. Okay, and then what? And then I draw the straight line tangent to the curve. So that will be N. Okay, any question? So how do you get the slope? You do it by derivative. Okay, you do it by derivative. So all the slope of the straight lines at each point on the curve, you get it by what? By derivative. And derivative is related to the slope. Derivative is what? Dy dx. Okay, any question? So if you look at the particular, I draw another curve. Okay, I draw another curve. Katakan ni macam ni curve dia. Okay, y equal to f of x. Now I want to find the slope at that point A. How do I find the slope at point A? Cepat-cepat, how do I find the slope at point A? And then I want to find the slope at point B, at point C here. Okay, how do I find the slope now at point A, B, C, or for that matter, any point? How do I do it? Just on the graph. Okay, don't worry about the derivative, don't worry about anything. How do we do it?
Make a straight line at
You
the
draw
point.
just a straight line, tangent to the curve at that point. Tangent means what? Tangent means just touch. Okay, just touch the line at the curve. You cannot cross the line. Just touch. Okay, so that's it. And here, that's it. Here, that's that. Over here. Okay, here. Over there, there. Okay, so now for a nonlinear function, what can you say about the slope at all these points? Here you got slope, here's slope, here's slope, here's slope. Now, what can you say about the slope at every point here? At all these points?
Zero.
Zero. It's not zero. Okay. Maybe here zero lah. Okay. But what about the slope here? Slope here. Okay. What is the slope here at point A? Just look at the straight line. By now we should know. You know the shape of the straight line looking like that. So what can you say about the slope at point A?
Positive.
Positive. What about here? What about that point C?
Negative.
Negative. Okay. So for a nonlinear function, the slope can be zero, can be negative, can be positive, whatever. So the point is, the slope, different. And you don't know, you don't have any more constant slope. The slopes are different at any point. Okay, at any point the slope may be different. Example here. Or I go back to the one that I drew earlier. Here, same thing. If you look at those points A, B, C, D, E, the slopes are different. Okay, right. Any question? So that is the derivative. So the derivative, as you want to know it, okay, is what? Is to estimate the slope of a nonlinear function. How do we do it? We take the slope at a point. Okay, you take a slope at a point, and how do you measure? Do we measure it? We look at it later on. How do we do it? We just find the slope of the straight line, just tangent to the curve at that particular point. Right? So the slope of the straight line, tangent to the function at that particular point. So for that matter, it can be what? It can be any point. Okay, any point on the line. So that is the slope of at a point. Sometimes you call it instantaneous rate of change. So that is determined or that is measured by what? Measured by the derivative. And what is the derivative? Derivative is related to the slope, okay, for which we have discussed earlier. Delta x is very, very small. So you denote that by dy dx. So this is the notation for slope. Notation, not for slope, for derivative. Okay? Notation for derivative. You call it y. Here is y prime. Where you call it y prime with the comma up there. And here dy dx. Okay, dy dx. Here delta y, delta x. And they are related. Okay, they are related. Dy dx coming from here. All right. Okay. Any question? Anything? All right. Good. So now we are going to find the derivative. How do you get the derivative? So question next is how do we get the derivative? We know already, you know, for a function y equal to f of x, the derivative is y prime, it's dy dx. All right. We know already some concept about it. Okay, before we move on, I would like to just review a little bit about our attendance. Okay, I would like to show you attendance. This is the attendance, you know, that you do in Zoom. I said to you earlier last week, I think, for the 1 month, you know, when I check your attendance, I got to scramble your list because your first one, you didn't put the section number. Okay, so I told you to put section number, I think last week. Okay, last week. So make sure, okay, by today, please put in your section number. So for example, this student here, Ain Hanani, All right, Ain Hanani, for now, I don't know section number, so difficult for me to get your name. And she only come for 1 minute. Okay, I said earlier, if you want to come 1 minute, better don't come. Okay, because that is considered as absent. You see here, no Aisha. So, she come at 9 something, and then she left 1 minute later. Good, you know, good strategy. Okay, you just cheat yourself. You come 1 minute, cantik. Okay, this one. Okay, that's one. Okay, second. Okay, so what did I tell you? Put your section number. Okay, I write down here because I need to say a few times. You know, people just, I don't know whether we understand or we don't understand. I'm not sure. So section number. Okay, that's number 1. Section number, put okay, please. In Zoom, classroom, everything. Okay, Zoom, classroom. What else? What are the other medium that you have? Zoom, classroom. Itu yang penting sekali. Dalam WhatsApp tak apa. Alright. Okay. So here, you see here. I think that here I want to macam ni. When Muhammad Firdaus. He put 7. You don't have to put section 7. You put 7 pun dah cukup dah. I know it's section 7 lah. Alright. So this is an example. So everybody should put in your section number. And if you have space, okay, put metric number. Okay, metric number. Your Gmail tetap payah. Macam ni. Anis Ilya, section 7. Put the metric number. So senang lah. You know, it's easy for me. Okay. Correct. Now, I told you, put your name in the order of your class list. Okay, that is what I said. Put your name in the order of class list. But there are still a few people. Still, you know, whether you are absent when I give the announcement or you don't understand, I don't know. Okay. But there are still some people who didn't do that. Contoh, yeah, Haziq. Haziq, your name, what is your full name? Is this Haziq your name or Muhammad Haziq?
Muhammad Haziq, sir.
Muhammad Haziq. Letaklah Muhammad. Okay? For those people with your name, Muhammad ke, Ahmad ke, Nur ke, Nurul ke, I told you, when you put your name, put the order of your name in the class. So you start with your first name, your second. So this is the most important. This one second important. The third name tak ada, tak apa. But you put your first, second name. Susahlah saya nak pergi check Haziq. So if you have your name absent, okay, for that day, and if I send you a warning letter, absent, and you say you come, okay, that is because of what? Because I have problem looking for your name. Muhammad ramai, you know, Muhammad ramai. Buat apa letak Haziq? Letaklah Muhammad dulu. Letak MU pun tak apa. Okay? And then put your second name. Okay, Haziq. If you don't have space, tak payah letak full name, letak HSL, tak apa. But the first name ni yang paling important. In the order of the class list. And then put your section number. Okay? So if you still don't understand, macam one ni. 1 M. Okay, 1. The first thing is 1 because your name in the book, in the list is 1. Bukannya start dengan Firdaus. Okay, and then section. So susah lah to make sure. And then I don't know you know, if you put your name benda-benda macam ni susah lah saya. You know, this one. Anas Uwais. Okay, Anas Uwais, section 8. Cantik tu, section 8 bagus dah. No, Anas ni. Is this the name? Okay, Anas bagus. Your name is Anas Uwais, as per class list. Alright, and here one more example. Ria Fauzia Afrin. Her name consists of 3 parts. So she put first name, second name, third name. So easy for me to look at. Dia bukan letak Fauzia dulu. Okay, and then section 12. Section 12 pula ni. Apa section 12? If you are on section 12, you are not in my class. Hello, Ria. Are you here? Are you in section 12? If you are section 12, you better move to section 12. Okay, you don't belong here. Cantik dah nama dah betul. Nanti nama ada. Section pula, hitamnya 12. Aduh. Okay, is that clear? So I don't have to go through every name lah. Penat lah kan. Kita waste 1 hour macam tu. So for those people who have not done what I just mentioned, please do so. Okay, do so as soon as possible. For the sake of what? For the sake of efficiency. Okay, I don't know your middle name. You know, macam ni senang kan? So Adam lah, nama dia Adam ke Muhammad Adam? Adam ni Muhammad Adam ke Adam? Adam. Adam, nama dia Adam. Senang cerita. Adam. Senang sikit. Okay. So make sure if you have not done, do it yet. Do it now. Okay. Section number, your name in the order of the class list.
Sir, you mute.
Okay. Okay. So attendance, all right. So make sure buat cepat lah. All right. So that will be easy. Also in classroom. Okay. In classroom pun buat macam tu lah. Put your full name, like I said earlier. So that will be easy. Okay. Now, if you come, all right. We consider attendance, if your attendance is at least, okay, 80 minutes. Macam ni, 80 minutes, 78. Okay, ini 1 minute, 2 minutes. But if I will go through this, you know, sometimes, yeah.
So you didn't present the.
Oh yeah.
You didn't present.
I got to. Apa kita kena buat? Saya kena share screen. Sekejap. Mana pula pergi? I forgot to share screen. Okay. Ni screen saja. So saya cakap apa tadi? Saya dah lupa dah. So itulah. Alright. Make sure you put your full name as per your class list. And attendance, I know that some people, your name here, maybe attendance here 12 minutes, but that is not because of your coming 12 minutes. You have internet connection, some problem, but you rejoin. So I'm aware of that, okay? But there are some people, just 1 or 2 minutes. So if you just come 1 or 2 minutes, that's good, okay? Good for you. You are successful cheating yourself. Because you are considered absent juga. Because dalam ni ada record. Terus saya kata, if you want to come 2 minutes, baik dengan datang langsung.
Sir,
For the 1 or 2 minutes, there are 2 names. It's duplicate.
You know, sometimes I will check, you know, for those 1 or 2 minutes, I go down again because sometimes you re-enter. Okay, so when I say 1 or 2 minutes, not necessarily all people. Okay, I don't have
Yes,
the
sir.
detail, but there are a few, you know, who just check in 1 or 2 minutes and never come back. All right, but there are cases. Okay, there are cases because of the internet connection. So that one, don't worry. Okay, because I all right, I will check. Okay, I will go through. And there are 1 or 2 people because of your name. Okay, because of your name is not full. I cannot trace your name. So your name up to now is still absent. Okay, you never came to class. There are a few people. Okay, so I do not know whether they actually dropped or you are here, but your name still, you know, put your middle name or things like that. So that is the importance of putting your full name. Okay, so I think I don't have to make any more announcement lah lepas ni. I hope people paham. Okay, kalau tak faham lagi pun tak tahu lah. Okay, any question? Anything? So that is ada seorang lagi siapa nama Al Hassan. I got one name Al Hassan, tapi I don't have his name in the list. Because of this, I'm wasting my time. Already 15 minutes, you know, doing this, which is not necessary. Which is not necessary. We should be doing mathematics, but some people still didn't understand. I have to repeat myself a few times. So wasting your time, wasting my time. Okay, this is another student here. Ahnaf. Your name is not Ahnaf. Your name is Muhammad Ahnaf. Okay. Ini penatlah saya cari nama. Alright. So if you put your name like that in Zoom, in classroom, I will deduct marks. Okay. When I want to record your marks, I will take out a few points. Why? Because of my time looking for your name. So please, okay. If you understand me, do the change. If you don't understand me, WhatsApp me. Okay, you WhatsApp me on my personal phone. Ask me the question. What didn't you understand about this? Okay. So tak ada sebab, tak ada reason for not doing that. So I hope everybody will take the necessary action. Okay, so let's continue from where we left not last class, a few minutes ago. All right, so now we go back to the derivative. So now, how do you get the derivative? So that is what you want to do next. So what I will do, I'll give you the formula. Okay, the formula in order to do the derivative. So we will do it here. The derivative formula. Derivative formula. You have, of course, you know, the notation. I have y equal to f of x. Then the derivative of y prime equal to dy dx equal to f prime of x. There is another way of writing f prime of x. Or sometimes we just use f prime. So these are the common, okay? The common notation that we use for derivative. Now, in order to find derivative, life has been made easy for us. You don't have to remember anything. I mean, you don't have to know the idea behind it. We just do it by knowing the formula. So I will go right away into the formula of the derivative. So this is 9.4. Okay, 9.4, I will show you the formulas. So that is derivative formula number 1. Okay, okay, number 1. If you have a function x raised to the power n, where n is a real number, the n here is not an integer, n can be a real number. So this is called the power rule. It's a simple power rule. Now, if you have this type of function, how do you do the derivative? So this is called the power rule. Okay, power rule. Not powers of x rule. Panjang. It's power rule. Okay, so that is the power rule. If I have fx equal to x to the power of n, where n is a real number, then what is the derivative? F prime of x is equal to what? Is equal to n. You bring down the power, multiplied by x, reduce the power by 1. So you multiply by x, n minus 1. So that is the power rule. Okay, got it? You write down now. If you don't want to write down, make sure you have the book, because the formulas are in the book. But if you want to, if you forgot about this, it's good to write down. So the power rule is this. Example, if I have y equal to x to the power of 5. Now what is the derivative? Y prime, or I can use x. You can write only one, okay? I write here a few of them because just to be familiar with the different notation. Equal to what? You bring down the power, multiplied by x to the power of reduced by 1. So x to the power of 4. Okay? Now example number 2. If I have x to the power of negative 4.7, because x is a real number. Now what is y prime? Y prime is negative 4.7. Okay, multiplied by x. Reduce the power by 1. Now, negative 4.7 minus 1. What do we get?
Negative
Negative 5.7.
5.7. Okay, so this is two examples. So that is what you call the power rule. So let me check. Example. I think these examples are in the book. All right. So you have u to the power u of s to the power of 8, and then q to the power of 2 over 3. Okay, now q to the power of p equal to q to the power of 2 over 3. How do you get the derivative? Same rule. You bring down the power, so 2 over 3. And then the power becomes 2 over 3 minus 1. So 2 over 3 minus 1, you get what? Q to the power of negative 1 over 3.
Negative 1.
Negative 1 over 3, yeah? Okay. So what they do here, they take care of the negative sign, they bring it down. So you got 2 over 3 q to the power of 1 over 3. But you don't have to do that, okay? You can stop here. You can stop at q to the power of negative 1 over 3. Or you can do it in that way, it's okay. But you can stop there. Okay, all right. Now the other one you have here, c. Okay, square root of t. Now what is square root of t in terms of a number? You cannot differentiate. Oh yeah, there's another term. Derivative. Derivative, find derivative. Derivative is a noun. Okay, find the derivative. Derivative tu is a noun. Nama dia. Okay, nama benda tu, name. Is the name of the function. That's derivative. Now, the verb, right? The verb, that means the process of doing it. We call it differentiate. I didn't say earlier. So, differentiate y equal to f of x. So, when I say differentiate, means what? That's the process of doing it. What do you mean? What do you mean by differentiate y equal to x? That means I find the derivative. Find the derivative. Okay, I didn't say when you do some of the examples, then the word came out, differentiate the function. Differentiate function means find the derivative. Okay, all right. Now go back to that example. If I have square root of 3t or square root of x, how do you differentiate that? Okay, so you have your square root. So you have to write that in terms of number. What is the number square root? X to the power of what? Half. Okay, so when you got x to the power of half, what is the derivative? Y prime is equal to half multiplied by x, reduce the power by 1. So what do I get? I get negative half. Okay, so anything here, square root or whatever, you have to convert into number rule. All right, so that is power rule. So next rule. Next rule is a constant rule. Okay, any function, constant function, what is the derivative? Okay, you have just y equal to f of x equal to c, where c is a constant, any constant. Now, what is the derivative? You don't worry about benda ni. Okay, the limit ni tak payah bimbang. Kita tak pergi itu. Kita go to the formula je. What is the derivative? Derivative is what? 0. So for any constant, derivative is easy, 0. So give you an example. Let's say y equal to 112.7. All right, what is the derivative? 0. Say y equal to negative 1000. What is y prime? 0. So any constant, the derivative is 0. Okay, any for any constant. So derivative is 0. Okay, all right. Next. Okay, if I have, what do we call this? We call it coefficient rule. You have a coefficient, a number, c, multiplied by some function of x. You think of u of x term in x, that's terms in x. So you have here a constant, okay, a constant multiplied by what? Some terms in x. Or they call it u of x. Some terms in x. So how do you do the derivative? Okay, this is the rule. You have c multiplied by u of x, and then the derivative is what? The derivative is the constant multiplied by the derivative. So the constant, don't worry about the constant, okay? The constant will just follow the derivative. The constant will go with the derivative, okay? So you have the constant c multiplied by u prime of x. Okay, you got it? Okay. So here, example, let's say I have y, Let's say I have y equal to 21 multiplied by x to the power of 8.7. So the constant, you don't have to worry about the constant. The constant will just go with the derivative. So you just differentiate x, all right? So the derivative y prime f prime equal to what? Equal to 21. Okay, don't worry about that. 21, you can put the bracket, multiplied by 8.7, or you can put the bracket to indicate multiplication. X 8.7 minus 1, 7.7. So the constant will just go or follow the derivative. Okay, so that is called the coefficient rule. Okay, there are a few more examples there. So if you look at the book, example number 5, here 4x power 5, here half x to the power of 2 squared. So you buat C ya, okay? A dengan B itu very straightforward. Alright, here I have 5 over square root of Q. Square root of Q. Square root of Q, like Q. So you bring the square root, it becomes what? Q to the power of half. You bring it up. That's why I got negative half. So I have 5 Q to the power of negative half. Okay? Okay. So you don't worry about the constant. Just worry about Q to the power of negative half. So I differentiate Q to the power of negative half. All right. So what they do, they put a bracket on the derivative. You can also do like this. Okay. But what I didn't put the bracket. I just put bracket to the constant. So if we have that thing, y, no, let's say I use f of x. Let's say f of x equal to 5 Q to the power of negative half. Okay. Now, constant. Bagus tak ada buku tu tak bracket. Tak apalah, tak ada bracket pun tak apa. You just put a dot. So 5 multiplied by negative half. Saya buat bracket. Boleh put bracket. Negative half. Okay. And then you multiply by Q, negative half, you reduce by 1, that is negative 3 over 2. Simplify lah. So I have negative 5 over 2 multiplied by 1 over Q, 3 over 2. Or you can maintain it as negative 5 over 2, Q to the power of negative 3 over 2. Sampai sini pun dah cukup lah. You don't have to bring it down. You know. Sampai sini pun okay lah. Okay. And if you want to, you can put into decimal point. That will be equal to 5 over 2 is what? 5 over 2? 2.5, right? 2.5. 5 over 2. So you have negative 5 over 2 is 2.5. So I have negative 2.5 multiplied by Q. Okay, 3 over 2. What is it equal to? 3 over 2 or 1.5. Negative 1.5. You know, you make it into a decimal point. Okay, all right. So 3 rules. Constant rule, power rule, coefficient rule. Okay, rule number 4. In this part here, I think we have a few rules. We just go through a few of them, I mean all of them. Next rule is the derivative of the sum and difference. So in short, I have the sum rule, difference rule. Okay, all right. Now, you have more than one terms in X. You get u of x plus v of x. Now, not necessarily 2, can be 3, can be 4, you know, it can be 5, whatever. What you do here is you just apply the sum rule. Okay? All right, now just focus on the sum rule. Difference rule, tak payah buat dulu. We do it later. Okay, now what is the sum rule? I think everybody just read lah. Senang macam ni. Okay, what is the sum rule? Write down je. Okay. Okay. All right. So in short, what does the sum rule mean? You don't worry about all the terms. You just worry about what? You just worry about one term at a time. Okay. And then keep the plus sign. So you add all these derivatives. So you don't worry about all the terms. You just worry about one term at a time. Differentiate one term at a time, and then add them up. Okay. So you have what? I have y prime equal to u prime plus v prime. Now, if you have 3 terms, z prime. So it doesn't matter how many terms you have, you know, you can have more than 2. Okay, you can have more than 2, it doesn't matter. What you do here, I differentiate each term. You differentiate each term at a time. And then what? And then add everything. Add them. Okay? So that's what we call the sum rule. Example. Okay, example, we follow the example in the book. We have what? Okay, you have A, very easy. I got 3x plus 5. So 3x plus 5, I differentiate one term at a time. And then add them up. So what do I have here? 3x. What is the derivative of 3x? Okay, derivative of 3x. Okay, you do it now. 3x plus 5. What is the derivative of 3x?
3.
3. 5, constant, 0. So what do I get is 0. So solution for A, 0. Okay, B. All right, B, I have 4x cubed. Ini minus. You know, you don't have the difference rule yet. Okay, so this one tukar jadi plus. Okay, you tukar jadi plus. Kita minus, kita buat kemudian. And then we mix them up. So that one become a plus. Senang cerita. So plus. Okay, yang minus to become plus. So plus 2x squared plus 5x minus 3. So what you will do here, more than 2 terms. Doesn't matter, right? Doesn't matter how many terms. You just follow. So ni pun jadi add ni, plus 3. Okay, jadi plus 3. So first term, what is the derivative? Just tell me. What derivative? By now we should be able.
12x.
12x squared plus. Okay, keep plus sign tu sama je. For the second term, what do I have?
4x.
4x, yeah? 5. Okay, here 0. So that is the derivative. So we just worry about the derivative and then derivative of each term, and then what you do, you do the what do I call it? You do the addition. Okay, all right. Okay, now next is the difference rule. Now difference rule is where you have minus. Instead of a plus sign, you have a minus sign. So here u minus v. So what do? Same rule, but you keep the same sign. Okay, so in this case here, negative sign, minus. So same thing. Okay. So if you have u minus v, derivative is f prime equal what? Equal to u prime plus v prime. So you don't have to write u of x or v of x. You just write u plus v prime, u prime plus v prime. So for difference rule, I have y prime equal to u prime minus v prime or minus z prime, whatever. You can have more than 2 terms. Okay, so everything will be the same. The rule are the same. The only difference will be what? Will be the sign. So, example, kita follow balik example ni. Alright, we just use this example. So, instead of having positive kat sini, you put negative. Okay, so negative. I have 4x cubed minus, cantik lah semua minus. So everything is the same. What you have will be what? Just the minus sign. Okay. All right. So these are the rules in 9.4. So let's go to exercise 9.4. Here we go to exercise 9.4. 9.4, if you look there is a product rule. All the rules here is the what do you call it? The rules are related to the what we learned. So 9.4, I would like you to do questions. Look at 9.4. You can try, from number 4 up to number 14. There, all these things are the application of the rule. Okay, now I would like you to do one example. Okay, do one more. I would like you to do question number. You try to do question number 10. Okay, do it now. Do number 10. Number 10, addition 11. Number 10, I have the first term, 3x to the power 5. Minus. Okay, you got it? When you got it, just let me know. Okay? Somebody just tell me that you got it.
Yes, got it.
Okay, good. Everybody got it? All right. So I give you all those questions. All right. Just find. Okay. Now, what I want to do next is you want to look at the idea. All right, the idea of the slope of the line tangent to the curve at that particular point. So in order to establish that, I'll give you an example. Let's say I give you a simple example, y equal to x squared. Okay, y equal to x squared. The derivative, okay, the derivative. What is the derivative? Y prime f prime of x equal to what? 2x. So that is the derivative. All right. Now this derivative, like I said earlier, will give you what? Will give you the slope of the curve y equal to x squared at any point. Okay, at any point. So let's do that. So if I draw the graph of x squared, anybody remember how does the function x squared look like? Okay, x squared is non-linear curve. it passes through 0, 0. It looks something like this. So that is y equal to y prime plus y equal to x squared. So in order for you to find the slope at any point, here, wherever, what do? I use the derivative. The derivative is equal to y prime equal to 2x. So that expression, for your information, is also a function. Okay, that expression or function will give you the slope at any point of the function y equal to x squared. Any point. Okay, give me 1 point. Say, what point? Give me 1 point. What point do you want?
1, 0.
Apa ya lah, 0.
1, 2, 1, 2.
Give me x equal to 1. Okay, x equal to 1. So the x equal to 1. Now, when x equal to 1, the point of y, what is the value of y for x squared? X squared. Y equal to what? When x equal to 1, what is the value of y?
1.
Y is 1. Okay, because x squared. So 1. So that is 1. Now at x equal to 1, I don't want, you know already y equal to 1. All right. But I don't want y equal to 1. I want this, the derivative. I want the slope. Okay, the slope at x equal to 1. So how do I do that? I use the derivative. Substitute into y prime equal to f prime of x. So in order to see that better, I use f prime. So f prime at 1. Okay, because that is where x equal to 1. And of course, that is also the prime equal to what? Equal to 2 times 1. That is 2. So you know the derivative is 2. So what does it tell you the slope? What is the slope at that value, at that point, x equal to 1? What is the slope?
M is equal to 2.
The slope is 2. Okay. How do you show 2? We just show it by what? We know the slope is what? It's the slope of the straight line tangent to the curve at that point. So you draw the line tangent to the curve at that point 1. What is the value of that slope here? M is equal to 2. Which is what? Which is y prime at 2. Okay? All right. So now you can do it at any other point. Suppose you take another point here. Okay, point ni berapa ni? Katalah point ni 2. Okay, we proceed one by one. So let's say that point is equal to 2. All right, y is equal to 4. So you do the same thing. I want to find the derivative at 2. Okay, I want to find the derivative at 2. So you substitute. Okay, substitute. What do you get?
4.
You get 4. So the derivative is 4. Y prime at 2 equal to 4. Okay. Now, what does it mean? It means the slope of the curve at x equal to 2 is what? Is 4. And that is given by the slope of the tangent line just at that point. So the slope here is equal to 4. Okay, so the derivative will give you the slope at the point. So when we do the substitution, you got y prime equal to f prime 2 equal to 2 times 2, that is 4. So what? Number 1, that is the slope of y, of the curve, at what? At x equal to 2. Number 2, it's the slope of, how do you show it? Slope of the tangent line. Okay, of the tangent line at x equal to 2. So the slope is equal to 4. Oh, okay, you got it direct from there. You can say the slope is 4 at the beginning. Slope is 4. All right, the slope at the point is 4. So the slope at y at x equal to 2 is 4. I can put here 4. Come on. That is the particular point. All right. Okay. Any question? Anything? Okay. So for that, for this part, all right. For this part, I would like you to do this thing. Question number. Okay, question number. That will be 15 to 17. So what you do here, you just find the slope. Okay, the slope of the tangent line lah. So buat A cukup lah, instantaneous rate of change tu tak payah buat. Actually, we can think of it as same thing, all right? So you just answer part A, slope at the, use the derivative, okay? So you do like what we are doing now. You get the derivative, find the derivative at that particular point, okay? So I'll give you 15 to 17. So that is 9.4. Okay, I have 5 more minutes. So we go on. Okay, you move on to 9.5. I would like to look at the next formula. Okay, next formula is the product rule. 9.5, we have product rule, quotient rule. Now, product rule is this. You have 2 terms in X. They are multiplied to each other. So something like this. I have f of x equal to u times v. U are functions of x, v also a function of x. So think of it, u as terms in x. Okay, terms in x. You multiply to each other. Example would be here. You have y equal to 2x cubed plus 3x plus 1 multiplied to x squared plus 4. Siapa bercakap ni? Okay, plus x squared plus 4. So you have 2 terms in x multiplied to each other. So what do? You apply the product rule. All right. So what I want you to do, you do this. Muhammad Syafiq. Muhammad apa nama tadi? Muhammad Syafiq. Muhammad Syafiq. Tak payahlah cakap. Okay. Kalau nak cakap pasal benda ni lah. Syafiq. You want to talk? Okay, talk now. What do you want to say? Go ahead.
No, sir. It's supposed to stick.
Okay, you have the product rule. You have y equal to u times v. we make it short. Okay, it's u of x, v of x, and will be something like this: u of x multiplied by v of x. So in short, I don't have to put x lah. Example, 3x squared plus 3x plus 1 multiplied by all this. Now, how do you differentiate this thing? Okay, I want you to read and I want you to write down the formula. The formula is given here. Okay, I want you to write down. Okay, go ahead, write it down. And then make sense of the formula. Okay, when you write down, you can make sense of it. You can disregard the x, so that we have shorter terms. Okay, you look at the rule. Okay, do some thinking. If you haven't done already, if you know that already, that's good. But if you forgot or if you haven't do this thing, look at the formula. How is the pattern? Okay, you see the pattern there. How is the pattern? You have what? Okay, is done. I will need to write down. Everybody write. Okay, so what is the rule say? What does the rule say? What is f prime? You have what? You have u multiplied by v prime plus, okay, u plus, what is the second term here? V multiplied by what? U prime. So what can you say about the terms? Yeah. You can, you can rearrange as long as it will be equivalent. So what does it say here? It says, what? You just need to differentiate one term at a time, multiplied by the other term. Okay, so sometimes for me, I prefer to do it this way. Y prime is equal to what? You differentiate the first term, multiplied by the second, plus differentiate the second, multiplied by the first. U prime v plus v prime u. So this is what I prefer, If you look at the formula given in the book, they write it the other way around because they are more comfortable with this. What they do, u v prime, v u prime. So it doesn't matter. Okay, it doesn't matter the order. You can put the derivative second term, or me, because I've been doing this. I'm used to this thing. But they are equivalent. Okay, u prime v plus v prime u. All right, so that is the product rule. So now time's up. I will stop here. We will continue on. So I will look at an example, okay, and then we see how can we apply the rule. All right. Okay. So I'll give you a few questions. Practice those questions for 9.4. We are now already in 9. Okay. All right. Make sure you understand the concept. All right. The derivative, slope at the point, slope of the tangent curve, a tangent line to the curve at that particular point. Okay. All right. Good. So I will see you again. Anything? Any question? Any remark before we go?
Questions.
Okay. No question. Good. So I will see you again Wednesday. I remind you again, for those people who have not adjusted your name, please, okay, please do it now. Okay, please make the adjustment so that everybody will benefit. Okay, so I thank you. I'll see you again Wednesday. Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Thank you,
Okay,
sir.
thank you.
Salam, thank you, sir.
Waalaikumsalam.
Yeah, thank you, sir.
Thank you, sir.
Thank you,
Okay,
sir.
thank you.
Thank you, sir.
All right, thanks.